Look up at the night sky. It feels still, eternal, almost quiet. But out there, everything is moving, changing, becoming. The moon is drifting away from us, inch by inch. In the heart of Sagittarius, there's a cloud of alcohol vast enough to brew 400 trillion pints of beer. And far beyond, entire planets made of diamond sparkle in the dark. Everywhere you look, the universe is alive, breathing, spinning, growing, writing its story across billions of years. Tonight, we'll wander through that story, from stars that forge gold, to planets that rain glass, to the invisible forces that hold it all together. So get comfortable. Let the noise of the world fade away, and let's drift together through the quiet, where science becomes wonder and the universe whispers its secrets to those who listen. The moon, our quiet companion, is slowly leaving us. Every year, it drifts about 3.8 centimeters farther away, roughly the width of a fingertip. A tiny step for the moon, but over billions of years, a grand escape. When it first formed around 4.5 billion years ago, the moon was astonishingly close, only about 22,000 kilometers from Earth. Today, it orbits at 384,400 kilometers, 17 times farther than when it began. That widening distance changed everything about our planet. In those early days, Earth spun so fast that a single rotation lasted only 5 hours. The oceans rose into enormous tides, pulled by the newborn moon. Those tides dragged against the planet's rotation, slowing it down bit by bit, and that lost energy was transferred to the moon, pushing it outward, as if Earth's spin were gently throwing its partner away. Now, the moon still retreats, inch by inch. And in the distant future, when it's too far to perfectly cover the sun, total solar eclipses will cease to exist. It's a soft, eternal drift, a cosmic reminder that even the closest bonds in the universe are destined, slowly and silently, to change. The journey of sunlight. At the center of our solar system burns a single star, the sun. To us, it's a light in the sky. To the planets, it's everything. The sun makes up 99.86% of all the mass in our solar system. All the planets, moons, asteroids, and comets combined share barely a fraction of what it contains. Jupiter, the giant among them, isn't even 1,000th of the sun's weight. Every world you've ever heard of, every orbit, every moonrise, every shadow, exists because of that mass. Its gravity shapes the paths of planets, holds the distant comets in line, and keeps the solar system together like a cosmic heartbeat. Inside, nuclear fusion turns 600 million tons of hydrogen into helium every second, releasing the light that takes 8 minutes to cross the void and reach our eyes. We orbit not just around its light, but around its weight, the unseen gravity that binds us, and the energy that made life possible. Every heartbeat on Earth, every dawn that begins, is powered by that single star quietly burning at the center of everything we know. The sunlight that warms your face today began its journey long before you were born. It takes light only 8 minutes and 20 seconds to travel the 150 million kilometers from the sun to Earth. But before that, it spent up to 100,000 years just trying to escape the sun itself. Deep in the core, where temperatures reach 15 million degrees, atoms of hydrogen fuse into helium, releasing energy in the form of tiny photons, the first flickers of future daylight. But the sun's interior is so dense, those photons can't travel in straight lines. They'd bounce, scatter, and ricochet off countless particles, a random walk through a maze of plasma. Each collision steals their direction and their time, so that what should have been an instant becomes 100,000-year journey to the surface. Only when they finally break free do they rush across the void at light speed, 8 short minutes later, touching clouds, oceans, and the eyes that look up in wonder. Every sunrise is ancient light made new again, a reminder that warmth travels slowly and that even the quickest things in the universe take their time to reach us. The cloud of cosmic alcohol, far beyond our skies, in the constellation Sagittarius, floats one of the strangest wonders ever found, a giant cloud of alcohol, vast enough to brew 400 trillion pints of beer. It's called Sagittarius B2, a colossal cloud of gas and dust, spanning nearly 150 light years across and drifting about 26,000 light years from Earth. But this cosmic brewery wasn't born from magic. It's the quiet work of chemistry in the cold. Inside the cloud, temperatures hover near minus 170 degrees Celsius, and every grain of dust becomes a tiny lab bench. Atoms of carbon, hydrogen, and oxygen settle onto icy surfaces, and over time, through radiation, shock waves, and starlight, they fuse into more complex molecules. Among them is ethyl alcohol, the same kind found in wine and whiskey on Earth. When newborn stars flare to life nearby, their heat releases those frozen molecules into space, filling the region with drifting clouds of alcohol vapor. And there it lingers, a silent toast raised by the cosmos itself, a reminder that even in the emptiest corners of space, the universe is still mixing, blending, and creating, one molecule at a time. If you enjoy drifting through the stars with me, take a moment to subscribe and stay close. And if there's a story you'd like to fall asleep to next, leave a comment below. I might just dream it into the next video. The eternal storm of Jupiter. On Jupiter, there is a storm so vast that it could swallow our entire planet whole. A swirling oval of crimson clouds, raging without rest for more than 350 years. It's called the Great Red Spot, a hurricane the size of 3 Earths, spinning endlessly in the planet's southern hemisphere. Astronomers first saw it through a telescope in the 1600s, and it's been there ever since, churning, twisting, its winds reaching speeds of over 400 kilometers per hour. But what keeps it alive? Unlike storms on Earth, Jupiter has no land, no oceans, no solid surface to slow it down. It's a world made entirely of gas, so the red spot can keep spinning freely, feeding on the energy of surrounding jet streams, recycling heat and motion over centuries. Inside, clouds rise and fall in layers hundreds of kilometers deep, painting the storm in bands of rust, ochre, and cream. And though it's slowly shrinking, it still burns like an ember in Jupiter's endless sky, a living scar of wind and fire. The great red spot is more than a storm. It's a reminder of time itself, of how even chaos can find a way to endure. More stars than grains of sand. If you could stand on every beach, scoop up every handful of sand, and count each grain one by one, you'd still come up short, because there are more stars in the universe than there are grains of sand on all the beaches of Earth. Astronomers estimate there are around 10 to the power of 24 stars, a number so large it barely fits in language. 1,000,000,000,000,000 suns, scattered through billions of galaxies. And yet each of those stars is a sun in its own right, some larger than ours, some smaller, many with planets of their own. Somewhere out there, a world may be looking back at us, wondering the same thing. It's easy to feel small when you hear that. But the truth is, we are made of that same stardust, the same elements born in ancient stars, now gathered here, thinking about them. So when you hold a handful of sand, you're touching a reminder of just how infinite creation can be, and how much of it lives inside you. The death of a star. Every star is a balance between creation and collapse, gravity pulling in, and fusion pushing out. For millions or even billions of years, that balance holds. Until one day, it doesn't. When a massive star reaches the end of its fuel, its core begins to collapse under its own weight. The outer layers fall inward, then rebound in a titanic explosion, a supernova, bright enough to outshine an entire galaxy. What's left behind depends on the star's mass. If it was large but not enormous, its core becomes a neutron star, a sphere only about 20 kilometers wide, yet heavier than the sun itself. A teaspoon of its matter would weigh more than a mountain. But if the star was even larger, the collapse never stops. Gravity crushes everything into a single point of infinite density. A black hole so strong that not even light can escape. The star that once gave light to worlds ends as darkness itself, and yet its death seeds the universe with new elements, making worlds, life, and even us possible. In the end, the death of a star is not an ending at all. It's how the universe breathes. The planet that spins backward. Venus looks peaceful from afar, a golden world wrapped in clouds, glowing softly in the morning sky. But beneath that beauty lies one of the strangest motions in the solar system. Venus spins backward, while almost every other planet turns from west to east. Venus does the opposite. Its sun rises in the west and sets in the east. Scientists think it wasn't always this way. Perhaps a massive collision with another world knocked it off balance, or slow tidal forces from the sun gradually reversed its spin over millions of years. Its atmosphere, thick and heavy, flows around the planet faster than the surface itself, as if the sky is trying to correct what the planet cannot. Seen through a telescope, Venus shines with perfect calm, but inside that golden light, it's quietly defying the order of the solar system, spinning backward in solitude, a reminder that even the most beautiful worlds can turn in the opposite direction of everything else. Mercury's burning day and frozen night. Mercury is the closest planet to the sun, a small gray sphere scorched by light. Yet, despite its nearness to all that heat, it is also one of the coldest places in the solar system. That's because Mercury has almost no atmosphere, no blanket of air to trap warmth, no sky to scatter sunlight, no shield against the emptiness of space. Its weak gravity can't hold gases for long, and the solar wind blows them away like dust. When daylight strikes, the ground burns at 430 degrees Celsius, hot enough to melt lead. But when darkness falls, the heat vanishes into space, and the temperature plummets to minus 180 degrees Celsius, a swing of more than 600 degrees between night and day. So even at the edge of the sun's fire, Mercury remains frozen half the time, a world that proves warmth is not just about distance, but about what you can hold on to. The edge of forever. Every black hole has a boundary, a line you cannot cross and return. It's called the event horizon. It isn't a wall or a surface. There's nothing to touch, nothing to see. It's simply the place where escape becomes impossible, where gravity pulls so hard that even light cannot turn back. From far away, it looks like a perfect sphere of darkness, silhouetted against the stars. But to anything crossing that line, the universe itself seems to fall inward, stretching and slowing as time loses all meaning. For an outside observer, nothing ever truly passes through. Objects just appear to freeze, their light fading, red shifted into oblivion. But from within there is no pause, only the quiet descent into an unknown realm where space and time trade places. The event horizon is the ultimate boundary, not between places, but between what can be known and what can only be imagined. Beyond it, the universe keeps its deepest secrets. Where time slows to a stop, near a black hole, even time itself begins to bend. Gravity there isn't just strong, it's so powerful that it warps the very fabric of space-time. If you could watch a clock falling toward a black hole, you'd see its hands move slower and slower, until at the edge, the event horizon, they appear to stop completely. From far away, time seems frozen. But for the falling clock, time flows normally. A second still feels like a second. It's just that the rest of the universe has sped far ahead. This isn't science fiction. It's Einstein's general relativity, proven again and again by observation. Even near Earth, satellites orbiting high above tick ever so slightly faster than clocks on the ground because gravity here is weaker. Near a black hole, that difference becomes extreme. A few minutes near the horizon could mean years or centuries for the rest of the universe. So if you could look out from that edge, you might see time itself unfolding like a movie in fast forward, stars aging, galaxies drifting while your own heart beats just once. And somewhere out there, the universe keeps moving on. But for you, time has nearly stopped. The other side of a black hole. If a black hole is where everything disappears, then what would be the opposite? A place where everything emerges. Physicists call it a white hole, a mirror image of a black hole, where nothing can ever enter, and everything inside can only escape. In theory, it would shine brilliantly, pouring out light and matter, but never taking any in. Time itself would seem to flow in reverse, not collapsing inward but expanding outward, a cosmic fountain instead of a drain. No one has ever seen a white hole. They exist only in the mathematics of relativity, possible, but perhaps not real. Some scientists wonder if every black hole could be connected to one, a hidden doorway through space and time. A wormhole that ends not in destruction, but in release. Whether real or only imagined, white holes remind us that nature's equations often dream bigger than we do. The invisible universe. Look up at the night sky. Every star, every planet, every glowing galaxy you see makes up less than 5% of the universe. The rest is invisible. About 27% is dark matter. It doesn't shine, reflect, or absorb light, yet its gravity holds galaxies together like a hidden scaffolding beneath the stars. When astronomers measured how fast galaxies spin, they found something strange. The stars on the outer edges were moving far too fast. So there must be something else, invisible, massive, and everywhere, providing the missing gravity. It doesn't emit light, but we can still see its presence in the way its gravity bends starlight, a cosmic mirage known as gravitational lensing. Through these distortions, we trace the outlines of the invisible, a ghost map of the universe's true structure. But even dark matter is only part of the mystery. The remaining 68% belongs to something stranger still, dark energy. In the late 1990s, astronomers studied distant supernova, expecting to find the universe's expansion slowing down. Instead, it was speeding up. Something was pushing galaxies apart, working against gravity itself, a mysterious pressure woven into the fabric of space. That unknown force is dark energy, a cosmic repulsion stretching the universe faster every moment, and we have no idea what it truly is. Everything we've ever known, the atoms in your body, the warmth of the sun, the dust between stars, is just a thin layer of paint on an unseen cosmic canvas. 95% of existence is still a secret. And somewhere in that darkness, the universe is whispering the parts of its story we haven't learned to hear yet. When galaxies collide, right now across the quiet dark of the cosmos, a slow dance is underway. The Milky Way, our home galaxy, and Andromeda, our nearest galactic neighbor, are drifting toward each other at nearly 400 kilometers per second. It sounds fast, but on the scale of galaxies, it's more like two snowflakes falling toward one another in slow motion. In about 4 billion years, they'll finally meet. But it won't be a crash, at least not the way we imagine it. Stars are so far apart that most will pass silently between each other, never touching. Instead, gravity will pull and twist both galaxies into long, glowing ribbons of stars, streams of light curling through the void. Over hundreds of millions of years, those shapes will merge, until only one great galaxy remains, a new, larger system astronomers call Milkomeda. The night sky, if anyone were still here to see it, would be breathtaking, a vast swirl of stars filling the heavens, like the universe itself had bloomed a second time. Our sun may drift into a new orbit, the constellations we know dissolving into chaos, and yet the cosmic story will continue, as it always has, slowly, endlessly, beautifully rewriting itself. The distance of light. We often say light years and think of time, but a light year isn't a measure of when. It's a measure of where. It's the distance that light travels in one Earth year, about 9.46 trillion kilometers, or nearly 6 trillion miles. When you look at a star 100 light years away, you're not seeing it as it is, you're re-seeing it 100 years in the past, because that's how long its light has been crossing the darkness to reach you. Every night sky then is a kind of time machine, a window into billions of yesterdays still shining in the present. Light carries not just brightness, but memory, the record of where it came from and when. And so when you gaze at the stars, you're not looking up. You're looking back, the forest that outnumbers the stars. We often look up at the night sky and feel small beneath the Milky Way, a galaxy of hundreds of billions of stars, stretching beyond sight or imagination. But here on Earth, beneath our own thin sky, life has been quietly outnumbering the heavens. There are an estimated 3 trillion trees rooted across our planet, more than all the stars in the Milky Way combined. Each one a living engine, breathing in our carbon, exhaling the air we need to survive. Each one a small spark of order in a world of chaos, a reminder that the greatest abundance isn't always above us, but beneath our feet. The universe builds galaxies. Earth grows forests. Both are vast, both are beautiful, and both whisper the same truth. Life and light are everywhere, if you only remember to look. The great cosmic silence, far beyond the crowded webs of galaxies and glowing clusters of light, there stretches an emptiness so vast it almost defies imagination. Astronomers call it a supervoid, a region nearly 1 billion light years wide, with almost no galaxies at all. It lies within the tapestry of the cosmic web, the great structure that forms our universe. Most of space is not evenly filled. Matter gathers in long filaments of galaxies, and between them are enormous pockets of nothingness. This particular void, known as the Botez void, is one of the largest ever found. If the Milky Way were placed at its center, we would see almost no other galaxies for hundreds of millions of light years in every direction. It isn't truly empty. A few lonely galaxies drift inside, but compared to the rest of the universe, it is silence made visible. No starlight, no crowded clusters, just the quiet breath of space itself spreading endlessly outward, reminding us that even the universe needs its moments of stillness. The diamond planet, far beyond our solar system in the constellation of Cancer, orbits a world unlike any other we've ever found. Astronomers call it 55 Cancri E, a planet twice the size of Earth, locked in a fiery embrace with its star, and believed to be made largely of diamond. Its surface burns at over 2,000 degrees Celsius, but deep beneath that heat, immense pressure could have crystallized vast layers of carbon into glittering stone. If our guesses are right, this world is a literal gem, a planet of diamond, worth an estimated $26 million. That's a 26 followed by 30 zeros. Of course, no one will ever mine it. Its sky is a searing furnace, its surface a storm of molten carbon. But the thought lingers that somewhere out there, in the darkness between the stars, there's a planet made of diamond forever sparkling in silence, proof that the universe is richer than anything we could ever imagine. The star that could swallow Saturn. Far across the Milky Way, in the constellation Scutum, a giant star burns with quiet crimson light. It's called UY Scuti, and it is the largest known star ever measured. If it were placed where our sun now shines, its swollen surface would stretch all the way past Jupiter and even touch the orbit of Saturn. That's over 1,700 times the diameter of our sun. A single rotation of this star could take more than 3 years to complete. Yet for all its size, UY Scuti is fragile. Its outer layers are thin and delicate, a glowing fog of gas barely held by gravity. It burns its fuel so quickly that it will live only a few million years before collapsing in a violent supernova, scattering new elements across the galaxy. Every atom in your body, your carbon, your calcium, your gold, once came from explosions like that. UY Scuti is not just a star. It's a glimpse into our own beginnings, a cosmic forge so immense that entire worlds could hide within its light. The galaxy that smells like rum and tastes like raspberries. If you could drift through the center of our galaxy, you might notice something unexpected, a faint, sweet scent in the cosmic air. Astronomers studying clouds of gas and dust near the Milky Way's core discovered traces of a molecule called ethyl formate, the very same compound that gives raspberries their flavor and rum its warm, sugary aroma. That means, in a sense, the Milky Way smells faintly of rum and tastes like raspberries. Of course, space isn't something you could breathe or taste. The molecules are scattered across light years, suspended in the cold emptiness between stars. But through radio telescopes, we can detect their chemical fingerprints, tiny spectral lines that whisper what the universe is made of. And sometimes in those signals from deep space, we find reminders of home, that even in the vast dark, the chemistry of life and sweetness is written among the stars, the planet that could float. Among all the giants of our solar system, Saturn is the lightest of them all. Though it's wide enough to hold more than 700 Earths inside, it's made mostly of hydrogen and helium, the same gases that fuel stars. Because of that, Saturn's average density is lower than that of water. If you could find an ocean wide enough to hold it, a cosmic sea big enough for a planet, Saturn would float. Of course, such an ocean doesn't exist, but the image lingers, a golden world drifting on gentle waves of starlight, its rings rippling like reflections in the water. Even in the silence of space, Saturn reminds us that lightness and beauty often go hand in hand. The coldest place in the universe. In the vastness of space where stars burn and galaxies collide, there exists a place so cold it nearly touches nothingness itself. It's called the Boomerang Nebula, a cloud of gas and dust about 5,000 light years away in the constellation Centaurus. There, temperatures drop to minus 272 degrees Celsius, just 1 degree above absolute zero, the coldest possible temperature in the universe. The nebula's heart is a dying star, shedding its outer layers in a slow cosmic breath. As that gas expands, it cools, just like air from an aerosol can chills when it escapes. But here, the effect is far more extreme. The gas moves outward so fast, it cools beyond even the natural chill of space. No planet, no moon, no shadowed crater is as cold as this drifting cloud, a frozen halo glowing faintly in the dark. The Boomerang Nebula is a paradox, born of heat, yet defined by cold, a dying star that became the coldest thing in existence. The planet where a day is longer than a year. Venus glows softly in our sky, bright and serene. But beneath its beauty lies one of the strangest rhythms in the solar system. A single day on Venus, the time it takes to spin once on its axis, lasts about 243 Earth days. But its year, the time it takes to orbit the Sun, is only 225 days. That means the Venusian day is longer than its year. And because Venus rotates backward, its sun rises in the west and sets in the east, a world where time itself seems to move in reverse. Imagine standing there beneath thick yellow clouds and an atmosphere 90 times heavier than Earth's, watching the sun crawl slowly across the sky, taking months to set as the planet drifts once around its star. On Venus, days stretch into eternity, and years pass like fleeting moments, a world where even time burns at a different pace. Jupiter, the guardian of Earth. Out there beyond Mars, a giant keeps watch. Jupiter, the largest planet in the solar system, is more than a world of storms and stripes. It's our silent protector, With a mass more than 300 times that of Earth, its gravity shapes the orbits of countless asteroids and comets that drift through the outer solar system. Many of those icy wanderers could one day fall toward the inner planets, toward us, if not for Jupiter's pull. Its immense gravity deflects them, captures some, and flings others harmlessly away into the dark. Like a cosmic shield, Jupiter absorbs impacts that might otherwise end life on Earth before it began. In its clouds, lightning flashes for eternity, storms the size of worlds rage, and yet, through all that chaos, it guards the fragile calm of home. Every sunrise, every ocean, every breath of wind on Earth owes a quiet debt to the giant that stands between us and the void. When metal becomes one, in the silence of space, things behave differently. If two pieces of the same metal touch each other out there, with no air, no dust, no barrier between them, they don't just meet, they fuse. It's called cold welding, a strange effect that happens in a vacuum, where nothing separates one surface from another. On Earth, air and moisture form an invisible layer that keeps metals apart, no matter how tightly they press together. But in space, there's no such protection. The atoms at the edge of one piece see the atoms of the other and can't tell the difference. To them, it's all the same metal, so they simply join. Two tools, two panels, two fragments of machinery touch once, and they become one solid piece. Engineers designing spacecraft must remember this, using coatings and lubricants to keep the universe from quietly welding their work together. Cold welding, a reminder that in the vacuum of space, even silence can forge bonds stronger than fire. The zombie stars. In the deep silence of space, some stars die and then somehow come back to life. They're called zombie stars, remnants of once sun-like stars that have burned through their fuel and collapsed into dense, fading white dwarfs. A white dwarf is the ghost of a star, no longer burning, just glowing faintly with leftover heat. But sometimes, if it orbits close to another star, something strange happens. Its gravity begins to pull gas and matter from its living companion, stealing it, piece by piece, layer by layer. As the stolen material piles up, pressure builds again, and the dead star can briefly ignite, flaring back to life in a brilliant burst called a nova. For a short time, the zombie star shines like it once did, a flash of rebirth in the dark before fading again into quiet ash. It's a reminder that even in death, the universe finds ways to burn again, to rise, to repeat, to glow once more. You can't burp in space. On Earth, burping is simple. Gas rises in your stomach, separates from the liquid, and escapes with a sound you hope no one hears. But in space, it doesn't work that way. Without gravity, there's nothing to pull heavy liquids downward and let the gas rise to the top. Inside your stomach, bubbles of air, liquid, and food all stay mixed together in a floating soup. So when astronauts try to burp, it's not just gas that comes up. It's everything. That's why in zero gravity, a burp becomes something far less pleasant and far more dangerous for your spacesuit. Astronauts call it wet burping, and they do their best to avoid it. It's a small reminder that even the simplest things on Earth, like a burp, depend on gravity to keep the universe in polite order. The planet that's only gone around once. Far beyond the warmth of the sun, where daylight fades into deep blue darkness, circles a world named Neptune, the most distant planet in our solar system. It was discovered in 1846, and since that moment it has continued its slow, graceful orbit around the sun. But Neptune moves so far away, and its path is so vast, that it takes 165 Earth years to complete just one revolution. That means, since its discovery, Neptune has only finished a single orbit. One Neptune year equals the lifetime of generations. While we've measured time by clocks and calendars, Neptune has been marking a single circle in silence. A reminder that out there at the edge of sunlight, time flows on a slower scale. A human lifetime is a heartbeat to Earth, but to Neptune, it's barely a blink. The planets you can't stand on. In pictures, the giant planets look like worlds you could visit. Swirling clouds, glowing bands, rings hanging in the dark. But if you ever tried to land on them, you'd never touch ground. Jupiter, Saturn, Uranus, and Neptune are made almost entirely of gas and fluid. They don't have solid surfaces like Earth or Mars. If you fell into Jupiter, you'd pass through thick layers of clouds, ammonia, hydrogen, helium, crushed by pressure 1,000 times stronger than anything on Earth. The deeper you go, the hotter and denser it becomes, until gas turns to liquid metal, and gravity itself ends the journey. There's no surface to stand on, no place to plant a flag, no sound of footsteps, just endless depth. These are not planets you walk upon. They are planets you fall into. Floating giants, beautiful and untouchable, forever keeping their secrets beneath the clouds. The visitors that never arrive. Every year, somewhere above our skies, a rock the size of a car slips quietly into Earth's atmosphere. It's an asteroid, a tiny fragment left over from the dawn of the solar system, a traveler billions of years old. But before it ever reaches the ground, friction with the air tears it apart. It flares bright and brief, burning into light and dust. To us, it appears as a meteor, a streak across the sky, gone in seconds. Asteroids like that enter our atmosphere roughly once a year, and almost all of them burn up completely before they ever touch the Earth. Our planet's atmosphere, thin as it seems, is a perfect shield, turning danger into beauty with nothing more than air and fire. A quiet reminder that every falling star you see might have once been something vast, and that, tonight, the sky just protected you again. The dinosaurs are still out there. Light doesn't travel instantly. It moves at a fixed, patient speed, 299,792 kilometers per second. So when we look at the stars, we're not seeing them as they are. We're seeing them as they were. Every beam of starlight is a message sent long ago. Now imagine a planet 65 million light years away, a world orbiting some distant sun, with telescopes far beyond anything we can build. If they looked toward Earth right now, their eyes would be seeing our planet as it was 65 million years ago. They'd see jungles full of ferns and thunder, vast oceans, and great shapes moving through the mist, dinosaurs roaming a world that, for them, still exists. Because the light of that ancient Earth is only now reaching their skies. For us, the dinosaurs are long gone. But somewhere out there, on the far edge of the universe, their story is still unfolding, written in light, still on its way. When galaxies eat galaxies, in the great darkness of the universe, galaxies are not still. They drift, collide, and sometimes they consume. Astronomers call it galactic cannibalism, when a massive galaxy's gravity pulls in a smaller one, tearing it apart star by star. The process can take billions of years. At first, the smaller galaxy is stretched into long, glowing stellar streams, ribbons of light left behind like trails of cosmic dust. Eventually, its stars are absorbed, its shape erased, its identity lost to the larger host. Even our own Milky Way has done this before, and it's doing it again right now, devouring tiny dwarf galaxies that wander too close. Someday it too will be consumed, when Andromeda arrives in 4 billion years, and the two will merge into one. Galactic cannibalism sounds violent, but in the vast timescales of the cosmos, it's more like a slow, silent embrace, the universe reshaping itself one star at a time. The edge of what we can see. When we look out into the night sky, we're not just seeing distance, we're seeing time. Every beam of light takes ages to arrive, so the farther we look, the further back we see. But even light has a limit. The universe itself is expanding, space stretching, carrying galaxies away faster and faster. That means there's a horizon, a place beyond which light hasn't had time to reach us yet. We call it the observable universe, and its edge lies about 46 billion light years away in every direction. Beyond that, there's more, perhaps infinitely more, but no signal from that distance will ever touch us. The universe is 13.8 billion years old. Yet because of cosmic expansion, we can see 46 billion light years, the past stretched by the growth of space itself. So when you gaze at the stars, you're looking into a cosmic bubble, a glowing sphere of everything we can know, floating in an ocean we'll never reach. The long road across the galaxy. The Milky Way looks peaceful in the sky, a soft, silvery river of light. But that river is enormous, a spiral galaxy nearly 100,000 light years across. That means even if you could travel at the speed of light, the fastest speed in the universe, it would still take you over 100,000 years to cross from one side to the other. Light, the very thing that defines fast, would spend 100 millennia just passing through our home galaxy. Inside that span lie hundreds of billions of stars, countless worlds, and distances so vast they blur the line between space and time. So when you look up at the Milky Way, you're not seeing a place, you're seeing an ocean of light so wide that even light itself moves through it slowly. A galaxy you could never cross, but one you belong to completely. The planet where it rains glass. Far beyond our solar system, there's a world where the sky itself is made of storms. It's called HD 18,973b, a gas giant about 64 light-years away, locked so close to its star that its dayside burns a deep cobalt blue. But that blue isn't an ocean, it's glass. Tiny particles of silicate float in the upper atmosphere, reflecting starlight like shards of crystal. And in the fierce winds that roar across the planet, winds over 7,000 kilometers per hour, those glass particles become knives, blasting sideways through the air in endless storms of molten rain. No solid ground, no calm sky, just a world where beauty and destruction are the same thing. A sapphire planet, forever tearing itself apart in the light. The heaviest teaspoon in the universe. When a massive star dies, its core collapses under its own gravity, crushing matter into something denser than almost anything imaginable. What's left is a neutron star, a city-sized sphere with more mass than the sun. Inside, atoms no longer exist. Electrons and protons are squeezed together into pure neutrons, a solid ocean of subatomic matter. If you could somehow scoop up just 1 teaspoon of it and bring it to Earth, that tiny bit would weigh about 1 billion tons, as much as every mountain, every skyscraper, and every ship on the ocean combined. Its gravity so intense that a pebble dropped on its surface would hit the ground at nearly the speed of light. Neutron stars are what's left when the universe folds matter into itself, where mass becomes memory, and even a spoonful can outweigh a world. The illusion of Saturn's rings. From a distance, Saturn's rings look smooth, like perfect, solid bands painted across the planet's golden light. But up close, they dissolve into motion. The rings aren't solid at all. They're made of countless fragments of ice and rock, orbiting side by side in an endless dance around the planet. Some are no bigger than a grain of sand, others the size of houses, all moving at thousands of kilometers per hour. Together, they stretch more than 280,000 kilometers wide, but they're so thin that if you scaled Saturn down to the size of a basketball, its rings would be thinner than a sheet of paper. They shimmer in sunlight like dust in a beam, millions of tiny mirrors, frozen and falling forever, forming something that looks solid only from far away. An illusion of perfection, built from chaos, glowing softly in the dark. The footprints that will outlast us. In the gray dust of the moon, there are still footprints. They were made by human hands and boots more than 50 years ago, the marks left by the Apollo astronauts when we first set foot on another world. And they're still there, on earth, wind, and rain, would erase them in hours. But the moon has no air, no weather, no water, and almost no change at all. There's nothing to wash the dust away. So those footprints and the tracks of lunar rovers and the faint impressions of flags and tools could last for millions of years. Only a meteor strike or future landing could disturb them. So somewhere on that silent gray surface, the memory of our first steps beyond home still waits, untouched, unchanged, a quiet testament to the moment humanity looked up and decided to go. The stars that forged gold. Far beyond our skies, where gravity and light blur together, two neutron stars drift closer, the crushed hearts of long-dead suns, each no larger than a city, yet heavier than our sun. For millions of years they orbit, spiraling inward, their dance tightening as they steal energy from space itself. And then they collide. In a single instant, they release more power than all the stars in the galaxy combined. Mountains of matter are torn apart, temperatures soar to billions of degrees, and atomic nuclei fuse in one of the most violent reactions known. Out of that chaos, gold and platinum are born. Atoms forged in the blast, scattered across the cosmos to drift for eons, until one day some of them found their way into Earth and into us. Every ring, every coin, every spark of gold on your skin is the echo of a stellar collision, a memory of two dying suns that briefly became alchemists. The sun's impossible heat. The sun, our steady source of light and warmth, burns at about 15 million degrees Celsius in its core. That's where hydrogen atoms fuse into helium, releasing the energy that makes life possible. But here's the mystery. As you move outward from the core, the sun should get cooler, and it does until you reach the edge. Then, suddenly, it gets hotter again, much hotter. The sun's outer atmosphere, the corona, soars to millions of degrees hotter than the surface below it. A region that should be fading into space instead erupts with invisible fire. Scientists still don't fully understand why. Some think it's due to twisting magnetic fields, snapping, and releasing bursts of energy. Others suspect waves of plasma carry heat upward in ways we can barely model. Whatever the cause, it's one of the great puzzles of solar physics, a reminder that even the star we see every day still keeps secrets in its light. The sun, so close, remains quietly unsolved. And so, our journey drifts to a close. From the moon's slow escape, to clouds of cosmic alcohol, to diamond worlds and invisible matter shaping everything we see. Tonight, we've wandered through wonders both near and unseen. The universe will keep moving, quietly, endlessly, and somewhere in that motion, there will always be more stories to tell. Thank you for listening, for sharing a moment of quiet wonder in a universe that never stops moving. If you'd like more stories like this, subscribe and tell me in the comments what you'd love to dream about next. Until next time, close your eyes and the cosmos will take it from here.